Okay, we're going to talk a little bit about inverse trigonometric functions. When we start off this topic, let's first of all go over what a function is. So if we have two sets, on this set we have A, B, C, and in this set we have E, F, G. If A maps onto B maps onto F, C maps onto G, this is a function. If we have the same again, say we have A, B, C, D, E, F, G. Here we have a spare D. This is not a function. Also, if we have a set here and a set here, A, B, C, E, F, G, that maps onto this maps onto this, but also C maps onto F, that is a function. So sometimes we can write out a function, say if we have in numbers, if we had like minus 2, 0, 5, 3, minus 1, 4. So we had this mapping onto here, we had the 0 mapping onto the minus 1, we had the 5 mapping onto the minus 1. If we write this out as x and y, we have minus 2, 3, 0, minus 1, and 5, minus 1. If we look at the x values, and if they're all different, then it's a function. So this is a function. We don't really look at the y values, we look at the x values, and if they're all the values are different, then it's a function. Again, if there's a spare x value at the bottom, say there was a 6 which didn't map onto anything, then that wouldn't be a function. Now it's a function going in this direction, but it's not an inverse function going in the other direction, because when we're going in the other directions we'd have 2 minus 1s as the x values going on to a y. When we're looking at trig functions, if we make two sets, we have 30 degrees, 45 degrees, 90 degrees. This maps onto, when we're doing inverse functions, maps onto a half, 45 maps onto square root of 2 over 2, and 90 maps onto 1. That's a function. However, if we have 150 degrees and say 135 degrees, 150 degrees is 180 minus 30, so that would also map onto the half. With 135, that would map onto the 45. So here we have some other values which also map onto the same elements in this. With an inverse function, we put in sides of triangles, and the output we get is an angle. So we go in the other direction. When we go in the opposite direction, which is the inverse, it's not a function. We can look at this in terms of a sine graph. So if we have a sine graph, it passes the vertical line test, so it's a function. However, it doesn't pass the horizontal line test, so the inverse of that curve is not a function. So how do we keep inverse trigonometric functions as functions? We do this by restricting the domain so we restrict the domain. So for example, in this sine curve, we'd restrict the domain to minus pi over 2 and pi over 2, and we'd be left with, if we bring that down here, so minus pi over 2, the sine curve would be here, goes down here and across there. So we restrict the domain, and when we apply our vertical line test, it passes, and when we apply our horizontal line test, passes as well. So what does that mean? So this means that within the restricted domain for sine, for minus pi over 2 and pi over 2, it passes the vertical line test, so it is a function, and it passes the horizontal line test, saying that the inverse of this curve is also a function. For trigonometric functions, we restrict the domain for it to act as a function. For theta equals inverse sine x, we restricted the domain to minus pi over 2 and pi over 2. For theta equals cos, inverse cos, we restrict the domain from 0 to pi, and for theta equals inverse tan, we restrict the domain to minus pi over 2 to pi over 2. Where we've got these brackets, the minus pi over 2 and pi over 2 are included. Where we've got this for tan, minus pi over 2 and pi over 2 are not included because minus pi over 2 tan is undefined. So minus pi over 2 is excluded, and similarly at pi over 2 tan is undefined. If we look at this in a pictorial form using our quadrants 4 quadrants in a unit circle. So sine, we only consider the inverse to be in quadrants 1, if in quadrants 1 and 4. Cos only in quadrants 1 and 2, and tan only in quadrants. If we look at the range, this is from -1 to 1. This is from -1 again to 1, and this is from -infinity to infinity. When we talk about inverse trigonometric functions, sine to the -1 is called arc sine. Cos -1, arc cos. And tan -1 is arc tan. If we want to draw the arc sine or arc cos functions, we have to remember that the inverse of a function is its reflection in the y equals x axis. Or we can swap x and y axis. So what do we mean by this? So if we have, let's have a sine over here. So if we have a sine curve, and it goes down here. So here we have the x equals y, or y equals x axis, and we want to reflect in that axis. What do we get? We get a curve that goes like this, and then it goes around like that, and similarly, because this follows around like that, it would go like this here. So this is the original sine curve. Let's draw it a little bit lighter. And that is the arc sine. If we want to draw both, where we swap the x and the y axis, so this would then become say half pi here, and minus half pi over here. So our arc sine would go something like this. And our sine, our arc cos would go from here and up to the minus half, like that. So this is arc sine, x, and this is arc cos x. When doing questions involving inverse trigonometric functions, we have to remember the restricted domains and bear that in mind. So for inverse sine, it's minus 90 degrees to 90 degrees. For inverse cos, it's from 0 to 180 degrees, and for tan, it's from minus 90 to 90 degrees. So those are restricted domains for the ranges minus 1 to 1. Okay, so if we had inverse cosine a half, this would fall, if we draw our quadrant, so this would fall, a half would be in this quadrant. And does that fall between minus 90 and 90 degrees? Yes, it does. So that's 60 degrees. If we have inverse cosine minus square root of 3 over 2, draw a quadrant diagram. Now minus 3 over 2, where is cos minus? It's minus in this quadrant here. Does that fall between 0 and 180? Yes, it does. And it works out as 30 degrees here, but we actually want this angle, which is 180 minus 30, which is 150 degrees, or 5 pi over 6. Sine, inverse sine, minus 3 over 2. So let's draw a little quadrant diagram. Where does minus 3 over 2 fall? It falls where sine is. Minus all positive here, sine positive there. So minus 3 over 2 falls here, which is 60 degrees. That's where sine is minus, and this is minus 60 degrees, or minus pi over 3. So always check that it falls within the restricted domain. Okay, so let's go on to our next one. Inverse cos minus 2 over 2. So where would this fall? So minus 2 over 2 in the restricted domain falls, cosine would be, sine is positive, C-A-S-T, sine, so negative here and negative here. So over here it doesn't fall within the domain, so it can't be in this quadrant, so it has to be in this quadrant, 0 to 180 degrees. So it's 3 pi over 4. Sine to the minus 1, sine pi over 6 equals. So let's have a look. So sine pi over 6, that's inverse sine of pi over 6 is a half, So this becomes sine inverse of a half, and that is pi over 6. Okay. Remember, for inverse trig functions, we're putting in the sides of a triangle and getting out an angle. So if we were given tan inverse sine 5 over 13 equals tan theta, we draw our triangle. So for sine, sine is opposite over hypotenuse, so our opposite is 5 and our hypotenuse is 13, which makes our adjacent side to theta 12. So tan theta would be 5 over 12, which is opposite over adjacent. So look at tan inverse sine x. So we draw our triangle. This time, if we look at our hypotenuse, call that 1. So from Pythagoras we have a squared plus b squared equals 1 squared. So our a squared equals 1 minus x squared. So if we call this x, this becomes 1 square root of 1 minus x squared, as a equals square root of 1 minus x squared. So our tan theta being there, is x all over square root of 1 minus x squared. We can rationalize the denominator and we get equals x 1 minus x squared all over 1 minus x squared.